Hello everyone, this is Andy Melbuff, and in this video we're going to take a look at again how we can check student input formats using the pattern function in Desmos Activity Builder. Now, as we saw earlier in a previous video, it's sometimes important to us math teachers to have students demonstrate they understand how different formats look. And so here's an example of asking students to input the equation of a line in slope-intercept form. And what we want is that y equals 3x plus 7 look. And if a student types that in, the teacher can see on the dashboard a check mark. There's a correct check built into this. But other versions of this that are algebraically equivalent would also be correct. For example, this has the equivalence of 3x plus 7 on the right-hand side of the equation, but it's not really the format we want. Likely here, just like this, with this 3, I could have 6 divided by 2, and that's equivalent-wise to 3x plus 7. But again, we don't want that format. We want students to demonstrate they understand a specific format. So we can go into pattern finding again and checking patterns to make sure that that is done correctly. So this is the exact same question. And if a student types in y equals 3x plus 7, we see the check mark here. Everything is good. But watch what happens if I do what I did earlier. I change that to plus 4 plus 3. A warning symbol comes up, an error message over here. And if the student hovers over it, it says not in correct form. You'll also notice the submit button is disabled. So we could put in this error message as a subtle way to prod the students in a certain direction. You can make this error message as simple or sophisticated as you'd like, and in a way it helps them move along without shutting them down completely. Here's another version that we saw a few moments ago, 7 plus 3x. Now, that also gets the warning symbol because the order is not correct. So we're going to take a look behind the scenes at what this pattern function can do to prompt students to enter the correct format. So entering edit mode here. Again, all of my computation layer is in the input down here, and we're going to build upon what we did in the previous video. So I'm going to go a little bit quicker with some of these parts. We're going to represent the function patterns with the variable p. And again, we're going to represent the variables that we want to use using patterns literal. Now, in this case, we're going to be expecting students to enter 2 variables. So we're extending what we did in the previous video. We're now going to have 2 variables defined, x and y. So students must use the variables x and y. That's what that part shaded tells you. Then we need to have formats that we desire. So I created this variable. I'm calling it desired LHS. And what that refers to is the desired left-hand side of the equation. What do we want to see left of the equal sign when the student inputs? Well, all we want the student to input left of the equal sign is the variable y. And I've already defined y a couple lines above, so this part's pretty simple and straightforward. Then let's think about the right-hand side. What do we want this to look like? We want the right-hand side to look like 3x plus 7. The right-hand side of this is a sum of 2 terms. So we're going to be using sum again. The first term is 3x. So that first term is made up of a product of an integer and a variable. The second term in our sum is made up of just an integer, similar to what we saw before. So back here in the computation layer, besides a desired left-hand side of the equation, I'm going to have a desired right-hand side of the equation. Now here's our sum of 2 terms. The first term is going to consist of a product of a number times the variable x, and the second part of our sum is going to be a number. Now again, I can substitute easily in here in place of number. I can make it integer, and that fits in well with this problem. Notice at the end I have strict order again. Basically that's saying keep the order as I indicate here for checking the student response. Now, here's a part that's going to be new to us. Because the student is entering an equation and we have to compare two different parts, we need to apply a new variable. And this is what I call a parsing situation. The student input is going to be parsed or separated into two parts. So I'm going to create this variable I'm calling answer, and I'm going to use parse equation. Basically, that's going to say we're going to separate into two parts in this component, whatever's typed in the LaTeX. We're going to separate it into two parts. And then what I want to do is compare again, like I did in the previous video. I want to have a correct left-hand side be equal to the desired left-hand side as long as it matches the left-hand side of my parsed answer. Now, I know that seems a little confusing there, but we're just tying together these different pieces. I also want to have a correct right-hand side that's going to be equal to the desired right-hand side when it matches the parsed answer's right-hand side. So this is kind of an extension forward from what we did in the previous video. Then my error message will look the same as before, except this time I need two things to be checked: a correct left-hand side and a correct right-hand side. When both of those occur, nothing shows up in the error message. No warning triangle, and the submit button is available to be used. But if both of those don't show up, the student gets this message right here, and the submit button is disabled. Lastly, I have a correct check down here, similar to what I had in the previous video, but I want you to look at this part. Now I have two parts to have correct: a correct left-hand side of the equation as well as a correct right-hand side of the equation. The last piece we're going to look at here, and probably the more sophisticated of the two pieces, can we use patterns to check for example, point slope form in Algebra 1 level mathematics, okay? What we want the student to demonstrate is they understand how this point slope form works, where we substitute x and y coordinates in to a certain format. Now, what we don't want students to do is solve for y, which a lot of students will do. So they will look at this and they will type in y equals 3x minus 1, which is algebraically equivalent, but it's not the format we want to see. So we get this little error message, same as before. So let's take a look behind the scenes, under the hood, if you will, at the computation layer. So looking at our computation layer here in the background, there's a lot of similarity. So hopefully this is becoming familiar looking. We're going to represent the patterns function with the letter P. We're going to define variables x and y, being literally x and y, so that the students have to use variables x and y. And then let's move to our desired two sides of the equation. I've got a desired left-hand side of the equation that I want students to submit, and a desired right-hand side. First, the left-hand side. I have a little note here. What I want students to type in on the left is y minus 2. So my left-hand side is going to be a difference of two terms. And the first term I want to be y. The second term I want to be a number. This can be a number, or again, it can be an integer. It depends on how you want to talk about your formatting there. So right here, we'll take care of the desired left-hand side of the equation, which we want to be y minus 2. On the right-hand side of the equation, the format we want is 3 times x minus 1. So what that is a product of a difference of numbers. So inside the parentheses is a difference of numbers. It's a difference of x and the number 1. Here's how we do this part. And I want the product outside of that. Okay, so we're going to use the product of a number and the difference of x and that number. And then, like we did in the previous one, I'm going to take and make an answer variable that parses the student's LaTeX input. It separates into the two parts. We're going to have a correct left-hand side that hopefully will equal the desired left-hand side as long as it matches the answer's LHS. left-hand side. And same thing with the right-hand side, and the rest of this looks pretty much familiar as what we just saw. Notice down here, because we're asking students to type in y minus 2, I can't use simple function to check for correctness. So I can't check the numeric validity of what they're typing in. All we can do is check their form. So if a student were to type in y minus 2 equals 3, x minus 1, no warning symbol, check mark. If the student were to take this minus 2 and add it over here, you can see a warning symbol pops up, an error message saying not in correct form because this 2 is on the wrong side of the equation. Likewise, if the student distributed again, we get that same error message. So using patterns here allows us to check for student understanding in particular formats. Thanks.